Hello folks, welcome to our next lesson, which is piecewise functions. This one will be a little confusing, so stick with me here for just a bit. The way we're going to start this is we're going to start by looking at two different equations, two different function graphs. If you're confused or if you need help figuring these out, remember that you can always just create a table of values with x and y going from -3 all the way up to 3. For this first equation, y is equal to 1x plus 0. What is that? Well, we start at the origin, our y-intercept is 0, and we move up 1 over 1, and so on. So this makes the line like that. Right, what about for this equation? If you don't remember how to draw an absolute value, we go back to our table of values. So, what's the absolute value of -3? It's +3. Absolute value of -2 is +2. +1, 0, 1, 2, and 3. Now let's plot out these points. So starting at -3, we go all the way up to 3. -2 we're at +2. -1 we're at 1. 0 we're at 0. And we continue to move our way up. Now this is going to create a V, but let's look at this in a different way. What we see is this half looks just like the half of this equation. However, this half looks different. If we were to continue this down, we would get a line with negative slope, whereas this would just be our same line from over in equation 1. So this brings us to piecewise functions. The way we can write this out is we can actually write this as two separate equations. We can say that this is going to be y is equal to x, 1x plus 0, for certain conditions, but it also looked like it was negative x. Where did this look like negative x? Well, it looked like that for everything to the left side of 0. Looked like that for everything to the left side of 0. And for positive x, it looked like that, that's the black line, everything to the right of 0. And we'll include 0 in there. So this is the idea of a piecewise function. It's the idea that you have a graph that is represented by different functions at different values. What a piecewise function is a function where the output changes based on your x value. So let's walk through how we create piecewise functions. There's typically two different ways that we can do this, based off of a graph or based off of trying to create a graph. So we can try to find the function or we can try to find the equation. Let's start with this first one where we're going to be trying to find the function. Looking at this, it looks like we have three different parts. We have some part that only works to the left side of this. That is, this line is only to the left of this. We have another line that works in between these two. We have a final one that only works to the left. So we can think about this almost like an inequality, where we say, okay, well, we have something that starts at x is less than 1/2. We're looking at this, we see there's something that only applies to the left side of negative 1/2. If we're looking at this, where does this apply between? Well, it's everything greater than 1/2, but also smaller than whatever this is. So this is everything between negative 1/2 and greater than or less than 2. Now notice this one has a filled in dot here. So just like the way that we would do inequalities, if it's a shaded dot, that means we have a less than or equals to sign. So when we're looking at this, what we know is we have a function that only applies when x is less than or equal to negative 1/2, only applies to this side of that line. We have one that applies in between, which would be this one. We have one that only applies when x is going to be less than 2. Only applies to everything right of 2. And now what we're going to do is we're going to figure out what each of these equations are. So looking at this, what's our slope? Well, we rise up 1 for every 2 we run, which meaning that this would be our next point. If we were to continue this along, we would see that we get our y-intercept right there. So this would be the line. What's our m? It's 1/2 x. And what's our b? It's minus 3 over 2, or 1.5. So that would be this equation for this part. What about the next equation? What does this line look like? Well, it has 0 slope, so it's 0x. And what's our y-intercept? It's 1. So this is the line 1. And this last one's tricky. We're going to have to move it all the way back to find its y-intercept. What's its slope, however? Well, it looks like it goes up 3 over the course of 1. So it's 3 over 1. And now let's move this back. If we go down, 1, 2, 3. Let's erase this so it gets a little less messy. If we move this, we go down 1, 2, 3 over 1. Down 1, 2, 3 over 1. So where would this line be? Looks like its y-intercept is all the way down at minus 4. So if we look at this, what we see is that our piecewise function, the way we write this is y is, we put in a fancy bracket here. Well, it's going to be 1/2 x minus 3/2 when x is less than or equal to 1.5. Does that make sense? Let's look at this line. What is 1/2 x minus 3/2? Actually, we'll do this on your calculator. So we have 1/2 x minus 3/2 for x is less than or equal to 1.5. We have 1 in between where x is 1.5, where x is 1.5 and x is 2. And then we have 3x minus 4 for x is less than 2. That should be greater than 2. Now, you can actually do that on your calculator. So let's put this into our calculator and see whether it comes out the same. Now here I have a graphing calculator. Let's try putting this in. If we're going to graph this, we need to go to the y equals menu to put in what our equations are. Our first equation is 1/2 x minus 3 over 2. And now the way we try to put in this next part is we can divide this by parentheses. X, and to get this less than or equals sign, we need a test. We're trying to test whether x is less than or equal to negative 1/2. So we're trying to get to test here, which we do by pressing second math. We scroll down to where we see less than or equal to minus 1.5. Let's graph that and see what happens. So we get the line 1/2 x minus 3/2, but it stops right at this point. Now, if we want to check the next part, we can say it's 1. In the same way, the comma, instead of a comma, we're going to divide by and put this in parentheses. So we're going to say that's minus 1.5. To get to this inequality, we have to test. So we're going to press second test and find the inequality we want. So we get negative 1.5 is less than x. Now we need less than or equal to 2. And let's graph that. Let's see what it does. Oh, that one did not work. Interesting. Now I'm not certain why this one's showing up as an entire line. However, for right now, we know that it should just be between those 2 points. And then we can also put in our last equation, 3x minus 4. Again, instead of a comma, we're going to divide by parentheses whatever this is. So x, to get to that greater than, we go into our test menu, put in the greater than 2. And now let's see how this looks. So for looking, we see we got that part down. If this were only in that one region, it would make sense. And we also have our line shooting up. So you can do these in your calculator. All you have to do is you put in whatever the equation is, you divide instead of a comma, and you put in your inequality. So now that we know how to do this, going from the graph to the equation, where we look, we figure out where these graphs have fences. And we'll discuss fences a little bit more. But we figure that out, we find the equations, and then we mark them in. We're going to do the same thing, but in reverse. So this time, we have x plus 2 if x is less than or equal to minus 1. So let's go to minus 1, and let's draw a line. Now this line is going to act as a fence, right? It's between the first equation and the second equation. It's the fence. Because this is less than or equal to, we know that whatever is on this side is the owner of the fence. So it's going to place its dot wherever it wants to. We have our fence here, and this side is the not owner. So this separates the two sides. These are the two grumpy neighbors. And where does this grumpy neighbor start? Well, let's work our way back. If we knew that this was x plus 2, or to start, we know we start at 2, and then we go back down. So instead of going up and over, we're going to go down and over. We go down 1, down 1, down 1. And where does this leave us? Well, let's erase the dot that's on the wrong side. It's on the wrong side of the fence. It's not over on that. The neighbor doesn't want it to be there. And what we're left with on this side is our line moving down like that. Now this is the owner, so it gets the dot right there. What about 3x minus 2? Well, let's look at that. We start at minus 2. We go all the way up, 1, 2, 3, over. 1, 2, 3, over. We go down, 1, 2, 3, we go over. Now this one does not own the fence. This fence separates them, so we can go all the way up to it, but not touch it. So this line owns this side of the land, meaning that we can draw this line out on this side. X plus 2 owns all the land less than or equal to minus 1, so it gets its dot and it gets this side. 3x minus 2 owns all the land greater than minus 1. It gets to draw on this side, but it doesn't get its own dot. Let's put this into our calculator and see if we get the same answer. To put this into our calculator, what do? We put in the equation, so we put in x plus 2. Instead of a comma, we divide, and we put in parentheses what our inequality is. So x, get to our test menu, less than or equal to minus 1. Close that out. Let's look at our next one as well. So we put in 3x minus 2, divide instead of comma, put in x, go to our test menu, greater than minus 1. And let's see how that graph looks. Looks pretty close to what we got, so that looks like we're on the right track here. We're going to do 2 more of each of these to make sure that we have a decent understanding. For this, we're going to write the function for each of these. This is going to be a little long. Let's only write the function for these first three. We're going to ignore this one. So looking at this, where are our fences? Looks like we have a fence right here. This blocks one side and allows things on the other. So where's that fence at? That fence is at -5. Everything on this side is going to be x is less than -5. Everything on this side is going to be greater than or equal to -5. But we have another fence here. Where's that fence? That is at -1. So we have a fence at -1. This dot again is open. And this function owns everything to that side. So what is everything to that side? It's everything greater than or equal to -1 because we're including it. Gets to put up the fence. The other side just gets to get super close to it. What does that leave us with in the middle? Well, it's everything bigger than -5, including -5 because this is whatever that function is, that's its fence, greater than x, but it has to be less than -1. And it's not paying for the fence on that side, so it just gets to put a dot. Now let's start with the easiest one. Looking at this, we see our slope, if you can actually see that, is up 1 over 1. So the first equation is up 1 over 1, 1x, and we go through plus 1. And we said that's true for everything it owns on this side. Where's its land? Its land is x is greater than or equal to -1. What about this middle one? Well, that one's just flat, so that should just be a number. What number is that? Well, we go down 1 minus 2 to figure out what our line is. If we continued it on, it would go all the way out to -2 over here. So it's -2. What land does -2 own? Well, it owns everything between -5 and -1. And what about this one? This one's the hardest. We're going to need to back this one out. So we're looking, we see our slope is -1. So if we were to continue this, we'd have to go all the way down to right here to find our y-intercept. What's our y-intercept? It looks like it's -8. And the equation is -1x. What land does that function own? Well, it owns everything to the left side of -5. We'd put on our fancy squiggly bracket, and that would be our answer. Put that into your calculator to see whether that actually works out or not. And again, for this one, we're going to do the same thing. Let's set up our fences, set up our property lines. We have a property line at -2, and we have a property line at 0. So what owns the land to the left of -2? It's 2x plus 6. So let's start by putting in a -2 for 2x plus 6. If we do that, we find out that at -2, right, we put in a -2 for -2x plus 6. We get that this is -4 plus 6, or 2. So we can start at 2, and it owns that land, so it gets to put its dot there. And now we go backwards, so we make our slope. So we go up 2 over 2, or in this case we're going the wrong way, so we go down 2 over 2. And that's our line. What about for -2x minus 2? Well, this one starts at 0, so we can say it's -2, but this one doesn't get to own the land. And it goes down in slope, meaning that it rises in reverse. And its dot would be right here. So we already have a dot there. We're good to go. And then we get 3x minus 2. So that starts at 2. It owns the land, so we'll fill in that dot. And it goes up 3 over 1. Up 3 over 1. And that's our graph. Let's put that into our calculator to make sure it's right again. So we start by putting 2x plus 6, divide instead of comma, x, where's our less than or equal to, minus 2. We put in negative 2x minus 2, divide instead of comma, put your parentheses. We get minus 2 is going to be less than x, which is going to be less than or equal to 0. And then we get 3x minus 2, and divide instead of comma, x is greater than 0. And if we look at that, this line looks right. That line looks wonky. Let's go back in, make sure we understand what's happening. Okay, so for some reason that one's not working. Apparently it doesn't like those ones bound on both sides, those neighbors on either side. But if we look and we continue that, we'd get the same line. And that one looks like I put in 3x plus 2 instead of minus. Yep, that one looks right. So this would be the correct graph. So that's the idea of a piecewise function. It's a function where what the input is can change what the function is. If we're looking at this, any values less than or equal to 2 get this function. Anything in between gets this function. So all we're doing now is we're putting multiple graphs together in parts of the graph. Where might this come in handy? Well, we have something like a stepwise function. What a stepwise function is let's say we're parking downtown. The cost of parking depends on how long you're there. You pay $1 for an hour, whether you're there for just 30 seconds or you're there all the way up until the hour. So what would this look like? Well, if x is less than or equal to 1, if our time is less than 1, that is not including it, how much do we pay? For any time under an hour, we pay $1. Right? For the next time, if we go just on a minute above that, so if we go up to 1 hour, or we go up to 2, we'd pay $2. So if this is our time, 1, 2, and this is our price, we start at 0 minutes. And even if we're there for 0 minutes, we have to pay the $1, all the way up until the 1 hour mark. As soon as we hit that 1 hour mark, we bump up to $2. And we're able to stay there for $2 for 2 minutes or 2 hours, 1 hour, 59 minutes, and 59 seconds, all the way up until the exact 2 hour mark where we'd bump up again. And this is called a stepwise function. A stepwise function is a function that has the same y value for all x. So this is a stepwise function. What a stepwise function is a function that has one y value for each interval of x. Meaning that it doesn't change until we get to the next number up, whether that's 1, 2, 3, and so on. Now there's actually a couple of places that use rules like this, like the post office. If you're mailing a book, and generally if you're just mailing, your price changes based off of what the actual value is. So if we were to make a graph of this, put our weight here, we would have our postage price over here. It starts off at $2.23. Starts there, no matter how small the package you're doing, all the way out until you reach 1 pound. Once you're more than 1 pound, and notice that this is less than or equals to, so we fill in that dot, we bump up about 30 cents. And any package between 1 and 2 pounds costs that amount of money. And then, if you just hit 2 pounds or above, you go all the way out to 3 pounds, and it costs you an additional 30 cents or so. So if we're trying to mail a book weighing 2.5 pounds, that would be right here, how much would this cost? It would cost us $2.93 to ship this book. So that's all we have for this lesson. I know this is a confusing topic. You have some homework on it. Make sure that you're feeling comfortable, that you're getting used to this. Put the answers up online and use your calculator to try to figure out if you're getting stuck. Go ahead and get working on that homework.